Chapter 4. Materials, Metals and Non-Metals. Part 2. In the previous part, we have already seen that what is metals and non-metals, and we try to understood about the reactions with the different kind of the chemical reaction with water and some chemical reaction. In this part, we will understand some reaction with the help of some activities which is there in your books. So let's start with that. First, we'll see activity 4.4. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. That means we have to take some amount of sulfur in a small spoon, and we have to heat it with the lamp, with the light. And if deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it and give it the shape shown in the figure 4.4a, as you can see over here. As you can see, this is one small metallic cap. You have to bind it with the wire and just put it into the burning sulfur powder. Now what if we have to do that? Cover the tumbler with a lid to ensure that the gas produced does not escape. That means when we heat that, some gas will be produced. It should not be come out of the tumbler. And remove the spoon after some time. And we have to understand what kind of the reaction or action it will be there, that we have to see. Now add some small quantity of water into the tumbler and quickly replace the lid. So when the water will add into the tumbler, there will be some reaction. Shake the tumbler well and check the solutions with the red and blue litmus paper. You have already seen in your lower class how the red and blue litmus papers come. Like this. You can see this water you have to take out in some small cap and you have to just check it out. If the litmus paper change the color, then it is acidic, otherwise it is not acidic. So the name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. That means when you add some water, what will happen? Some gas will be produced, and the name of the gas is sulfur dioxide gas with the reaction with the sulfur and oxygen. As you know that there is air, in the air there is oxygen. When the sulfur dioxide is dissolved in the water, sulfurous acid is the form. As I told you, if it is dissolved in the water, what will happen? The sulfurous acid is the form. And the reaction can be given as follows. So sulfur dioxide, that is SO2 plus water H2O, it convert into the sulfurous acid. So the equation of that H2SO3. Okay, so the reaction between sulfur dioxide and water convert into the sulfurous acid, that is H2SO3. So the sulfur acid turns blue litmus paper red. So that is acidic. That liquid is in the acidic liquid, and that the blue litmus paper is converted into the red color. Generally, oxide of non-metals are acidic in the nature. As I have already told you, if the non-metals are there, it is acidic in the normal nature. That means the blue litmus paper is converted into the red color. Now we'll see reaction with the water. What will happen when the metals comes in the contact with the water? Let us see how metals and non-metals react with the water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. That means sodium are very much reactive with the water in the nature, and it do different kind of the reaction with the oxygen and water. A lot of heat is generated in the reaction. That means when the sodium metal is come into the contact with the oxygen or water, too much heat is produced while they do for the reaction. It is therefore stored in the kerosene. That means we cannot store sodium in the normal or the normal outside area, because it is basically react with the oxygen that is in air and in the water. So normally we have to keep it in the kerosene and keep in the safe place, because if it is come into the air, it will do the reaction and the heat will be produced, and sometimes it may be blast also. Let us see activity 4.5. So now we have to understand how it is basically react. So we understand the activity 4.5. Here we have to take 250 ml beaker or the glass tumbler. Fill half of it with the water. That means in the 250 ml beaker, fill the half of this water, that is almost 125 ml. Now carefully cut a small piece of sodium metal and dry it using filter paper and wrap it in a small piece of cotton. That means if we are using the sodium, we cannot directly put into the water, otherwise it will do some all of us reaction and that may be blast. So first of all we have to dry it before we take it out from the kerosene. Put the sodium piece wrapped in the cotton into the beaker and observe carefully. When reaction stop touch the beaker, that means when the reaction is there into the beaker, what will happen? We have to check it out that. So what do you feel? Has the beaker comes hot? Test this solution with red and blue litmus paper. This we can do only with the practical. Here we cannot understand while we are going to do all these things, but we have to understand with this slide show, and you have to understand that if you have some sodium at home, so you can do the practice, but this practice is little bit not advisable to you because it is a little bit dangerous. So if you have sodium, kindly do the practice in front of the your some teachers or maybe your elder brother or some parent. Is the solution acidic or basic? That also you can check with the help of blue litmus paper and the red litmus paper. Here you can see the reaction of sodium with the water. That means in the beaker when you add some water and when you are putting some sodium, what will happen? It is converted into the heat form and it will be definitely heated. So you observe the sodium react vigorously with the water. Some other metals do not do so. So for example, iron react with the water very slowly. That means when you put some iron or some other materials in the water, it will not react directly. It will take some time to do some reaction with that. Generally, non-metals do not react with water, though they may be very reactive in air. Non-metals are not that much of reactive, but it is very good in the air. So such non-metals are stored in the water. So some metals, non-metals, are kept basically in the water. For example, phosphorus is very reactive non-metal. You might have seen the phosphorus in the lab. So in the lab, normally we keep phosphorus into the water. It catches fire if exposed to the air. To prevent the content of the phosphorus with atmospheric oxygen is stored in the water. So this is very much advisable to you that whenever we found the phosphorus, we must have to keep it in the water because when it comes in the contact with the air, it can catch the fires very easily and it can be exposed also. Let's see reaction with acid. How metals and non-metals behave with the acid, we'll see. Here we'll take the activity 4.6, which is there in the textbooks. Take some examples of metals and non-metals listed in the table 4.5. Separate the test tube and labels them A, B, C, D, E, and F. With the help of drop, add 5 ml of dilute hydrochloric acid to each test tube one by one. Observe the reaction carefully. If no reactions occurs in the cold solution, warm the test tube gently. That means we have to take 5 test tube A, B, C, D, E and F. In each test tube we have to add some 5 ml of hydrochloric acid and do some reaction while we are some heating that. Bringing a burning matchsticks near the mouth of the each test tube. That means some matchsticks we have to take it near to the mouth and we have to just do some observation, but that is also very much carefully we have to do that. Repeat the same activity using the dilute sulfuric acid instead of the dilute hydrochloric acid. That means here we have to take the two different solution, sulfuric acid and hydrochloric acid. Okay. Record your observation in table 4.5. How does it there? This is also one kind of activity that is also possible, that can be also possible only in the laboratory. So this is just for the understanding. So is there difference in the way metals and non-metals react with the acid? Of course, yes. What could the pop sound in some cases be due to when a burning matchstick is brought near the mouth of the test tubes? Some pop sound will be there because there is some reaction between match and the chemical. We must have found that non-metals generally do not react with acid, but metals react with acid and produce hydrogen gas that burns with the pop sound. That means whenever pop sound comes, you have to understand that some hydrogen gases basically come out. Clear? We must have noticed that copper does not react with dilute hydrochloric acid even on heating, but it reacts with the sulfuric acid. So copper is also one kind of the metal which does not react with the hydrochloric acid. Instead of that, on the heating, it will react with the sulfuric acid. Hope you understand this activity, and if we get time, we'll do this activity in the lab. Thank you.